Welcome back. This is Mr. Wakefield, and we're going to be looking at section 2.8 right now, right at the end of our packet. What we're going to be looking at here is something called a composite function. F circle G is how it's worded. That is not F times G. It's not multiplication. That's why you see the circle right there is open. It's an open circle, not to be confused with the open circles we were talking about with graphs earlier. But it's just an open circle, not a colored-in circle like it would be oftentimes with the multiplication symbol. All right, so this has nothing to do with multiplication, but what it is when it says F circle G, that is its own separate function right there, just like F of X would be a function, or G of X would be a function, okay? So just like F of X is a function, you guys remember that means what? That means that X is whatever the number is that's inside the parenthesis there, that gets plugged into the function formula, F of X. So like down here, if we had, say, F of 2, that would mean that we plug in 2, right, into the F of X here. And so how does that relate to this? Well, here, this is its own function too, where if you put like 2 into the X right here, you'd plug it into the F circle G formula. We're going to figure out what F circle G is coming up here, and depending on the problem that we have. But how does the whole thing work, though? Let's talk about that first. When it says F circle G, in that order, the order does matter, okay? That means that G of X is the thing that goes inside that parenthesis next to the F there. Okay, so instead of 2 going in there, or 3, or some normal constant number, we're now going to put an entire function inside of that bracket that goes next to the F. Okay, so if you haven't seen this before, if you haven't seen this in a while, be patient, all right? It's kind of an unusual thing, new thing here that we have, but we'll get through it here. So, again, just as a comparison, if we had, say we had G circle F and we put it in that order, okay, that would mean, again, the order does matter. So when you have G circle F in that order, it means that G is on the outside, and F of X would go on the inside of the bracket. So in other words, that would mean that instead of plugging in, like, again, let me give you a visual down here. If you have just regular G of X instead of G of F of X like this, G of X would look like what? Let's say I wanted to plug in 4, all right? The way that works is that whatever number gets replaced by the X right here replaces the X over here. So that means that the 4 would go right there. And that's the idea, you guys. Whatever is next to that outside variable, whether it's G right here or F up here, whatever is in that bracket next to that outside variable, that thing on the inside of the bracket replaces the X inside of the formula represented by that outside variable. Okay, don't worry, we'll be talking about that plenty more here, all right? I know that was a handful. Just like the 4 was in the bracket next to the outside variable, the 4 then replaces the variable on the other side of the equal sign. Just like the 2 is in the bracket next to the outside variable, the 2 then replaces the variable on the other side. So now, it's just that now, instead of having a normal number inside that bracket next to the outside variable, we now have an entire other function in there. All right, so let's see how that all works. Now, it says here that they want you to not just figure out F circle G with an X right here, but F circle G at 2. What that means, and there's more than one way to do this, but I'm going to first of all figure out what is F circle G of X. I'm going to figure that out first, all right? And then we will figure out what happens with the 2 right there, all right? F circle G of X is the same thing as, let me write it down here. Again, since the F comes first, the F is the outside variable, and since the G comes second, the G is the inside variable inside the bracket. Okay, so the idea, you guys, is that the outside variable, that's the formula you use. The outside formula, that's the formula you look at. All right, the inside variable, that's the one that you're going to plug into the variable of that outside formula. All right, so here's what you do. after you establish this, you then replace the inside part with what it's equal to. G of x, you guys, is equal to negative x plus 3. So what I do is I write down the fact that g of x is equal to negative x plus 3. I just replaced the g of x with what it's equal to. All right, I don't want to plug in the letters g and x there, all right? That's not the idea. We want to take whatever g of x is equal to, and that's the thing that I'm going to plug in. All right, so what does all that end up being equal to here? Well, again, let's say it one more time. Whatever is inside of that parenthesis, all right, next to the f, no matter what it is, it goes here. In fact, let's set it up here. Let me write this down over here to the side. F, whatever's inside that parenthesis, goes inside of this parenthesis over here, because that's how it works. Remember, we said that whatever goes inside this parenthesis goes here. All right, but whenever you plug something into a variable, you got to use an empty parenthesis so that it gets plugged in correctly. Okay, and so that's exactly why I wrote it like this. So whatever goes in here, whether it's a 2, and you can see that happen here with the 2. The 2 goes here, and then the 2 goes here. Just like that. All right. The 2 goes here, and the 2 goes here. We plug it in. All right. So if I plugged in, if I did f of 4, f of 4 would be 2 times 4 minus 3. F of 5 would be 2 times 5 minus 3. So whatever's inside that bracket is going to go here. So don't be alarmed by the fact, I know it's weird, but don't be alarmed by the fact that you don't have a number in here, all right? And we saw this a little bit earlier in the chapter where you have something that's not just a normal number here. But whatever's inside that bracket next to the outside variable, f here, that's the thing that goes into the variable for the other side of the function of f right here, okay? Whatever goes on the outside, whatever is inside there, let me just say it one more time, whatever goes inside of this bracket here, in this case it's negative x plus 3, that goes there. Because as we said, whatever's inside the bracket goes here, and that's where the variable is, okay? I just replaced the x with a bracket. So let's try it. F of negative x plus 3, okay? F of negative x plus 3, which is exactly what this is here, right? Isn't that what this is? F of negative x plus 3 is equal to, and let me give myself some room. Need to make my bracket big enough. All right, I'm not changing anything. I'm just making the bracket a little bit bigger. F of negative x plus 3, it says here to take that and put it here. And so that's what you do, okay? That's how you figure out the answer. And so let me just bring that down here, 2 times negative x plus 3 minus 3. Okay, I'm going to go ahead and simplify that answer, but the important thing is that we got the answer written down. When it's, again, we can do order of operations right here to figure out this answer, even though we don't normally do that with variables. Parentheses come first, but I can't do anything with the parentheses because I can't combine these terms since they're not like terms and we're adding them. Can't add together 2 terms that aren't like terms. But after I did the parenthesis here, we then have multiplication and then subtraction. So I distribute out the 2 because I got to do multiplication next. That would be negative 2x plus 6. And then the minus 3. Okay, and now so we're supposed to take that answer from the multiplication and subtract 3 with it. That means that, and anytime you got a polynomial being subtracted with a term, okay, that just means to combine like terms. And so our final answer there for that part is going to be negative 2x plus 3, because I combined the 6 and the 3 there. Okay, so f circle g of x is equal to negative 2x plus 3. All right. So, okay. So with that in mind, what is f circle g of 2? Okay, as they asked. Well, once you got that established, see, f circle g is now its own separate function now. We created a brand new function called f circle g that's a combination of f and g together. all right, where G got plugged into F. The second one always gets plugged into the first. Now that we've created a brand new function, and since it's equal to negative 2x plus 3, all you have to do now is just plug in the 2 into that. Because it says F circle G, which is its own separate function, all right, and then the 2 is next to it in a bracket. So that's just like any other time you got a bracket next to a function, you just plug that number into the x on the the F circle G is equal to here, all right. So since this is equal to negative 2x plus 3, F circle G is equal to negative 2x plus 3, that means that whatever number they put here is just going to get plugged into that, just like on any other function. What is this equal to? This is equal to negative 4 plus 3, which is negative 1. All right. And so that's the process there. Now, what happens, you guys, if we have G circle F? Same idea, it's just now the G is the outside part and F is the inside part, all right? To save myself some space here, let me get rid of the words there, what is, we don't need to say that, all right? It's going to be the same process as the last problem, it's just that the G goes first this time. All right, so G circle F of x is what? It is G on the outside, F on the inside, okay? And so what you want to do when you establish what's on the outside and what's on the inside is you want to establish now what the inside is, because we're not going to ultimately plug in the letters f and x. We're going to plug in whatever that's equal to. It says up here that f of x is 2x minus 3. So you just go up here and it tells you what f and g are equal to. F of x is 2x minus 3. So let me look at this again here. As you guys know, since g of x is equal to negative x plus 3. That means that whatever goes inside that parenthesis right there, that's why I erased it. I want to make it so you can see that anything will work here. Anything can get plugged in. If whatever goes inside that parenthesis right there has to go inside this parenthesis here. All right? Because whatever goes inside the x here goes inside the x here, like it always has been with functions. All right? So let's just practice this here. G of 3 is negative 3 plus 3. G of 5 is negative 5 plus 3. So G of this big thing right here would be negative this big thing right here plus 3. All right. In other words, whatever that thing is right there, whatever that thing is that's inside the bracket gets plugged into the outside function wherever that variable was for that outside function. All right. The inside function, which is 2x minus 3, gets plugged into the outside function and its formula, okay, which means you just put it wherever the variable is. All right, so let's do it again here. G of 2 is negative 2 plus 3. G of 4 is negative 4 plus 3. So G of 2x minus 3, all right, if you put 2x minus 3 here, it's going to go right there. In fact, let me write that out here. G of, let me just make the bracket a little bit bigger. So you can see here that whatever goes there, you guys, will go there. All right, just like we said here, the only difference is I made the bracket bigger to fit this thing in there. So G of 2x minus 3 is going to be 2x minus 3 right here. And so again, we can, let me write that down first. Let me write that down. So we got negative, I'm just going to transfer that down here. Simplifying that, parenthesis cannot be simplified. After parentheses comes multiplication. Remember, this means negative 1 times when you have a negative in the front of the problem there, like that, followed by a parenthesis. If I distribute negative 1, I get negative 2x plus 3. And then we have to add that result from the multiplication to the 3. All right, and that would be what? That would be negative 2x plus 6. So that is the part where we figure out what g of f of x is equal to. All right. All right. So now, now that we know what g circle f of x is, that's a whole new function now. All right. G circle f of x is negative 2 times x plus 6. So that means that whatever goes inside this bracket right here, and this time they say they want 3 to go in there. See how this thing right here in the problem they actually ask us, it's the same thing as this, except for they're replacing the x with a 3. Okay, so bringing that down here, we now realize that since g circle f of x is negative 2x plus 6, it would make sense then that if they put 3 in there, that the 3 then would replace the x on the other side, like we always do with functions. Whatever goes inside that bracket goes inside the bracket over here. What is this equal to? This is equal to negative 6 plus 6, which is equal to 0. Okay. All right. And so that is g circle f. So you can see that whether you have f first or g first, all right, the first letter is the outside function. The second letter is the one that you plug into the outside function. So the outside function is the one that you actually plug into. The inside function is the one that actually gets plugged in. Let me say that one more time. The outside function is the one that gets plugged into, and that's why I was talking about plugging into x right here in this second problem here. It's the inside function that gets plugged into that outside function. So inside gets plugged into outside. All right, that's why the inside function negative 2x minus 3, which is the same thing as f, and f is inside. The inside function gets plugged into the outside function, which is g of x, and that's why we plug the inside function into the x right here. Okay, and we saw that here. So inside gets plugged into outside. Now, last thing here, this one's going to look really unusual. G circle g. Okay, does that even make sense? Yeah, it does. It just means that you're going to plug a function into itself. But the rules are still the same, all right? G is both the outside and the inside at the same time. It's still true that the first letter is the outside and the second letter is the inside. It's just that now you're going to be what? Well, first of all, let's go through the same process. All right? The process doesn't change. You take the inside function, you establish what it's equal to. We know that g of x, just looking at the inside of the bracket here, inside of the bigger bracket, the g of x is negative x plus 3. So let's establish that. Okay. Now, it's still true that you plug the outer, or pardon me, you plug the inner into the outer function, all right, but you're just going to be plugging it into the same thing. So let's establish the outside function again with the empty parentheses here. All right, and I didn't make it big enough. Sorry about that. Let me fix that. There we go. So the inside function gets plugged into that outer function. The inner and outer are both the same this time, but the fact is that this is the outer function right here. Okay, the g is. So that inside function goes in there, and as you guys know now, whatever's inside that bracket over here next to the g, that goes over here automatically. And so that's how we figure it out. Okay. Now, what is all this equal to? Again, when you got a term times a bracket, and then the bracket ends, and then you have plus or minus a term outside here. As we found out in the last few problems, that means that we first of all distribute the negative 1. Okay, this is order of operations, but this is just an easier explanation than saying order of operations now that we've seen it a few times. Term times bracket and then plus or minus a term behind that bracket. It just means to distribute out the parenthesis first and then combine like terms with this term out here at the end. So negative 1, if I distribute that out, and let me go ahead and write it out here first, but if we distribute out that negative 1 that's in the front there, okay, just like we did in the last problem. So that's going to be x minus 3 on the distribution, right? We still have that plus 3 behind it, though. So combining like terms, the entire answer ends up being equal to x, okay? And so kind of an unusual answer, but that's how it comes out. So, by the way, it's not always going to be equal to x when you have the two things that are the same, in case you're asking that question. That's not how it works, but it's just a coincidence this time that it ended up being equal to that. So since g circle g, since that function is equal to x, then that means that g circle g with 2 in there, and again, let's read it carefully here. We got g circle g of x is equal to x, and so that means that g circle g of 2 means you just plug 2 into whatever g circle g was equal to, which is x. Well, since it's just x, then the 2, whatever is inside of this bracket here goes inside the variable over here. But the variable is the entire answer. And so it makes sense then that the answer would just be the same number. If this right here, x, is the same as the answer, x, then whatever goes inside that bracket will automatically be the answer. It's got to be the same. Just like x and x are the same, 2 and 2 are the same. All right. So the final answer there is 2. By the way, I know I circled the this first part here, x. That's not what they... Oh, you know what? I apologize. That is negative 2, isn't it? Excuse me. That is negative 2, not 2, that we're supposed to plug in there. But it's still the same idea. Whatever goes inside this bracket here ends up being the answer, because the entire function is just equal to that same variable that you're replacing the negative 2 with. X and x, negative 2 and negative 2. All right. So yeah, I know I circled the function answers here as well, but they really just wanted to know what happened when you plug in the number. Okay, but I just circled both because we got to get used to being able to figure out what the brand new function is first. All right, because we're going to be doing that here on the back side of the worksheet. So that's why I did that first there and made a big deal out of that before I actually plugged in the negative 2, or I plugged in the 3 on the last problem and all that. Okay, so now you have an idea of how F circle G and G circle F works, and those are the ones you're usually going to do. The G circle G thing is more rare, but it all has to come down to what? It comes down to the outer. Let me back up. It comes down to the inner getting plugged into the outer. Okay, the inner function is the one that gets plugged in. The outer function is the one that you plug it into. All right, and so that's it for the basic discussion on F circle G and G circle F. What we need to do right now, as we get ready to flip over the worksheet here, is we need to talk about the domain now of these composite functions. Okay, so now when we flip over to the back side of the worksheet, we're not only looking at composite functions F circle G and G circle F, but we're also looking at their domains now. So let's talk about that. First of all, in this first one here, let's just go ahead and figure out, as the directions say, let's figure out F circle G and G circle F, and then I'll talk about what the domain is going to be and how to figure that out, okay? First of all, as we learned on the front side of the worksheet, F circle G, it means that you're going to plug the second function G into the first function F, and the second function is the bigger one there, x squared plus x squared minus 4. All right, and so if we plug that into the first one here, that means it's going to go into this spot right here, right? And so let's see what that looks like. So plugging it into here, it's going to look like this. Remember to use your parentheses when you plug in. Okay. So the x gets replaced by a parenthesis there, the one that you're plugging into. And so it would then have the g plugged into that x after you put the parenthesis there to replace the x. And then the plus 2 is, of course, separate from that. Okay, so that is F circle G. I'll just go ahead and simplify this. When you have a bracket with nothing in front of it, just a bracket, nothing being multiplied in front of it, and then you're adding a term to that. You just combine like terms, okay? The bracket really doesn't make much difference there, mainly because there's nothing being multiplied by it on the outside. So it ends up being combining like terms, x to the fourth plus x squared minus 2. G circle F is similar. Okay. So we want to plug in, again, the second one this time. Let me write it out again. The second one is f of x this time. The g is the first one. So that means that we want to plug in the x plus 2 into these x's over here. A little bit more complicated, but again, replace the x's in the x's you want to plug into right here. Replace them with parentheses, and then we'll put the appropriate thing on the inside. Okay, and that appropriate thing, since it's the second function, it's going to be the x plus 2, like that. Okay. In fact, just to kind of skip a step here, which is okay, because we know what f of x is. F of x is the same thing as x plus 2 right here, right? It's the second function. So I'm just going to put it in there right now. No use in writing anything more than that. So the second function gets plugged into the first, so the x plus 2 gets plugged into the x's here, and this is exactly what it looks like. Okay, so here's the f circle g, here's the g circle f. Okay, so we figured it out. You can leave this, by the way. You don't have to distribute out those parentheses, okay? Not that you would distribute the 2 anyway. You would square it. Sorry, I meant to say 4 right there, not 2. It's supposed to be 4 right there because this is a 4 right here. Or pardon me. We're plugging into here. Excuse me. We're plugging into here, so the 4 should be here. It comes from there. We plugged into the x. The 2 then should be here, and we plugged into the x. Okay. So that is G circle F there. But yeah, you don't need to take this to the 4th power, and you don't need to take that to the 2nd power. You can leave it like that. But what is the domain all about, you guys? Okay. The domain, as we learned earlier, is in a previous discussion on domain, what we learned is that, and I'll go down here and remind you, okay, it's easiest to find the domain. This is from the front side of our current worksheet. It's easiest to find the domain by first finding out which x values make the radicand of any even-rooted radical. When I say even-rooted radical, in this case I'm referring to square roots, okay? But it would also work for 4th roots, 6th roots, and stuff like that. Okay, but it's just, right now we're just concerned about square roots. And then the radicand is the thing on the inside. So what they're saying is first find out which x values make the inside of a square root greater than or equal to 0. Let me say that one more time. Find out which x values make the inside of a square root greater than or equal to 0. Okay, then we need to be concerned about which x values make the denominator equal to 0. Now here's the thing, and again we discussed that in a previous discussion, but it's the inside of a square root, and it's when the denominator is equal to 0. Those are the things that you're concerned about when it comes to figuring out the domain. The inside of a square root can't be negative when you're doing domain, and that's why it's got to be greater than or equal to 0, like it says here, and the denominator can't be 0. So here's the thing, you guys. In these two composite functions, f circle g and g circle f, there are no square roots, and there are no denominators that could possibly be equal to 0. And so there's nothing that you have to remove from the domain. Normally, you'd have to remove those numbers that make the inside of our square root negative or the denominator equal to 0. So there's nothing to remove. Since there's nothing to remove, you guys, then if we make a number line like we did in a previous domain discussion, it would just be every single real number. Be everything on the number line would be in the domain. Everything. We don't have to remove anything like has been done in the past. Okay. And so everything goes in there. All right. Now, what I need to mention here, which I forgot to mention when I printed this out, is that we need to write the domain in what we call interval notation, which we've seen before. Okay, it's when you take the number line, okay, and you start at the left and whatever's shaded, okay, you go from left to right, whatever's shaded, that's how you do your interval notation, okay. By the way, here is that previous discussion I was referring to right here, okay, where when the denominator is equal to 0, you remove the number that makes it equal to 0. Okay, everything else was in there except for that, but we removed the 5/2 because that was what made the denominator equal to 0. Okay, and then whatever made the inside of the radical negative, so that's why we had to say greater than or equal to 0, because that's what would make it not negative, and those are the ones that we want to keep. Everything else that makes it negative we would get rid of. But again, so in this problem, again, no worries about that. So when we do the interval notation, just like we did here, okay, you start out the left, negative infinity, and then if there's a break in the graph, we put that in there. But again, there's no break in the graph right here in the current problem we're working at. So instead of doing negative infinity up to the break, we just take negative infinity all the way to infinity. Okay, and so let's do that. So it's going to be negative infinity all the way up to infinity, okay, for both of them, okay, for both of these, okay. So let me write that down. This domain, let me give myself some room here. This domain, which is negative infinity to infinity, is for both F circle G and G circle F. Okay? Because both of them do not have a denominator to worry about, and both of them do not have a square root to worry about. Okay, so that this domain is for both. So you don't need to say it twice as long as you make that note right there. Okay, because it did ask for the domain for both F circle G and G circle F. Now, so let's get to a little bit more of a complicated problem now. Okay, but we'll get through it here. Before I do that, though, I want to mention that I'm going to go ahead and skip number 6 right here. If you know number 4 and number 5, that should get you covered as far as getting your homework done and your classwork and whatever else you need to do, okay, that is related to this topic, okay. So let's go ahead and jump into it. Again, F circle G and G circle F. We just do the same thing we normally do, but the difference is that the domain is going to be a little bit tougher to deal with, but we'll go through it carefully, okay. So F circle G is F of, again, G is that right there. And so you need to plug that fraction into the x from f, because f is the first function. You're always supposed to plug into the first one. So it would look like what? It would look like this right here. Okay. All right. And so that's what F circle G is. Okay, so now here's the thing. We figured out what F circle G is. I'll do G circle F in a little bit here. Since the domains are going to be a little bit more complicated this time, let's go through it a little bit more carefully, okay? So we need, and again, looking at the front side of our worksheet here, okay, once again, a reminder, the first thing you want to do when you're trying to find the domain is focus on the inside of the radical. Make sure it's greater than or equal to 0. So what we do is we take the inside of the radical, okay, and we say that it's greater than or equal to 0, okay, and then we figure out what x values are gonna make that happen, and those are the ones that we want. the ones that make this negative, those are going to be out of this answer right here. Okay, when we solve this, it'll just give us the ones that are good, which are the ones that are greater than or equal to 0. Okay, now, here's the thing. We need to do a little bit of review here of something that was seen earlier in another discussion. Okay, and it was this right here. When you have a inequality like greater than or equal to, and you got a fraction in it, okay, what we did was we moved everything to one side so there was a 0. We already have that in this current problem. But then we had to make these two things into a single fraction, and then I'll kind of review the rest of this here as we go through it step by step. So the first thing we got to do is to make this into a single fraction here. Okay, you don't need this bracket right here, by the way. Normally you do, but you can discard it here because there's nothing being multiplied by it. It's not being taken to the second power or something like that. It's just when you have just a bracket plus something with nothing being multiplied or anything like that by the bracket, it's not necessary. The other thing we want to do, though, is we want to make the 4 into a fraction, because when you're adding a regular thing, a regular term to a fraction, you want to make that regular term into a fraction also. And then, as you guys now know from reviewing this in the past, or from doing it in the past, when you have, remember that when you're adding or subtracting fractions, you guys, you need a common denominator. So let's pull that off to the side. One thing here, though, you need to move that negative. If you have a negative in front of the first fraction, you're adding or subtracting fractions, you have to move it into the numerator so that it doesn't just get forgotten about, okay? It needs to be moved in there. And then we need a common denominator. The common denominator here, whenever you have just a one denominator and then the other one's equal to 1, okay? So if you have two denominators and one of them is equal to 1, the other denominator will automatically be your least common denominator. Okay, so it's x. Now this one's already got the denominator that we want, x, on the bottom, so don't change anything here. But this one, I need to multiply by x, because 1 times x is x. You have to multiply by the appropriate thing in order to get the denominator in place that you want, which is x. And so then we need to do 4 times x as well. And so now we have the same denominators. And again, you can't add these unless the denominators are the same. Once they are the same, the denominator stays the same in the answer. But then what's negative 2 plus 4x? Those are not like terms, and when you're adding terms that are not like terms, don't try to combine them. Instead, just say that they are being added without combining them like that. And so this thing right here, which was originally looks like this, I just rewrote it down here. It now transforms itself to this. I'm talking about the left side of the problem here, the left side of the inequality. It looks like this. Then, just like we did in the past, where you've got a single fraction on one side of an inequality here. Inequality is the one with the greater than or equal to, and then a 0 on the other side. What we do is we set the numerator and denominator equal to 0, and that tells you what numbers you're going to put on your number line, and we'll go from there then. And so let's do that step next. So we want to make this equal to 0. We want to make this equal to 0. This is already solved for because x is by itself, but how do we solve this one? Make that equal to 0. We then need to, since this is a normal linear equation, it's just x, not x squared or anything like that. You're gonna move the 2 over with the 0, and then you're gonna divide out like that. And that gives me, if I reduce that fraction right there, I get 2 divided by 2 is 1, 4 divided by 2 is 2. X is equal to 1/2. So what does that mean? That means, you guys, that those are the two numbers that you put on the number line. Okay, let's make a nice big number line this time to give us enough room. So put a 0 there and a 1/2 here. Put them with plenty of space in between to have enough room for each one of those intervals. Okay, and then just like we did in that previous problem I've been showing you here over the last few minutes, we then test out each interval to see which one is true or not. Okay? In other words, which one makes this fraction greater than or equal to 0? That's what we want. Those are the numbers that are going to be in the domain. So you plug in it just like we did in that example I just showed you there. You pick a number that's inside of each interval. Any number will work. It'll give you the right answer. Okay, so I'll go and pick, say, -1 right here. Okay, and I'm going to plug it into this fraction. Okay, and what do I get here? So I plug in -2 plus 4 times -1 all over -1 greater than or equal to 0. Is this true or false? Again, I plugged it into here. Okay. And I get what here? I get, I got to figure out what the top and bottom are equal to first. Then I try to divide. That's how you figure out what a fraction is when there's no variables in it. Multiplication comes before addition. So we end up getting -6 over -1, which of course is equal to 6. And we know that 6 is greater than or equal to 0. It's greater than 0. Okay. So that means that this entire interval, all the numbers in this interval are going to make the statement true when it said greater than or equal to 0. It's going to make this statement up here true. Okay, which means it's going to be greater than or equal to 0. All the numbers in here are going to be greater than or equal to 0 here, which means that they make the radicand greater than or equal to 0, and that means that those numbers right here are going to be in the domain. Okay, now this one's a little bit of a tougher one, between 0 and 1/2. Okay, 1/2, if you put that in your calculator, 1 divided by 2 is 0.5. So what's between 0 and 0.5? How about, I'll just do 0.1. How about that? Okay, you could do 0.2, 0.3, whatever. Let's plug that in. Plug it into the same fraction we did on the first part, like this. Your calculator will help you out here, okay, because you got decimals. Calculators are always helpful in that case. Figure out what the top's equal to first. So we get 4 times 0.1 according to your calculator is 0.4. Then when you add 0 to that, you get -2 plus 0.4 is -1.6. Okay, and I did not mean to say -0.1 on the bottom there. Excuse me. That should be positive 0.1. Okay, and so we end up with -1.6 divided by positive 0.1. If you put that in your calculator, that's equal to -16. You can write that down if you want. Okay, -16. All right. Is -16 greater than or equal to 0? No, it is not. Okay. Negative numbers are not greater than or equal to 0. So we keep this thing blank. All of these numbers are not going to be in the domain. They do not make that fraction true that we were talking about. Let's do the last interval here. Let's say we plug anything greater than 0.5. Let's do 1. You can do 2 or 3 if you want. But we'll do 1. And so we get what here? We get plugging in 1. We get this right here. True or false? True or false? Again, we figure out what the top's equal to first. And that's going to be equal to 2 on the top. 2 divided by 1, as you guys know, is equal to 2. Is 2 greater than 0? Greater than or equal to 0? Yes, it is, because it's greater than 0. Okay. Just has to be greater than or equal to 0. That's why we keep on saying that in order to be true. Since it's greater than 0, that's why I shaded it in. It's true. But if it's less than 0, like -16, that's why this one was false and we didn't shade it in. Now, as we learned in that discussion from that previous problem I was showing you here, when you're done with all your shadings, you've tested out all 3 intervals, you then do your brackets here to close up the shadings. Okay, if you have shadings that stop at a number, in other words, they're shaded on one side of the number but not the other side, you can see that's true with 0. It's shaded on the left but not the right. 1/2 is shaded on the right but not the left. Okay, you got to use a bracket to close that shading up. Okay, now the way that works is that if you have a greater than or equal to problem, in other words, it has the equal to in it there underneath the greater than. Same thing if it had been less than or equal to. Same thing if it has that equal to in it. Then normally these brackets would both be square. Okay, however, there is one exception to that, and that was seen here in this problem as well. This was greater than or equal to as well, but we changed this one to round bracket because whenever the denominator is equal to 0, and that is the case with 1, if you plug in 1 right here, that makes the denominator 0, and that's where this bracket is. You've got to always make that round if the number makes the denominator 0. So if it is got that equal to component in it here, okay, it would normally be always square. Okay, so normally we would do this. Normally we would say square and square, okay, but just the ones that make the denominator 0, and 0, if I plug the 0 into the denominator up here, whether you plug it into this one or this one, these are both equivalent statements here, okay. Either way, you're going to get a denominator of 0 if you plug in 0 right here. And so 0 is always going to be round, or whatever number makes the denominator equal to 0. It's always going to be round. Everything else that does not make the denominator equal to 0, it will be square if you have that equal to component on it. If the equal to component had not been on there, then this would be round as well. But the number that makes the denominator equal to 0, it's always round. So to review, the number that makes the denominator equal to 0 is always round no matter what, no matter whether you have the equal to component here in the inequality, but the other number is based on whether or not you have the equal to component. Okay, so the 1/2, because this has the equal to in it, that would be square. If it didn't have that equal, if it had just said greater than, then you'd make that round as well. So that is those are your numbers right there that make the radicand greater than or equal to 0, the thing inside the radical, and that's what you need. So those are the numbers, at least from the radical perspective, that make the are going to be in the domain. Okay, so we still have to consider the denominator, but we'll get to that in a minute. So what is the interval notation here for this? It's going to be negative infinity to 0. Let's write that down. Negative infinity to 0. Always use a round bracket with infinity or negative infinity. For 0, you use the same bracket that you use in the number line up here. Okay, same bracket. And then you put that u thing, okay, which is what we do. Whenever you have a break in the graph that's more than just a single number, but it's like a bigger break, you put that u right there. Okay, you got to put that there. When there's a shading that ends and then it starts back up again with a bigger gap like this, not just a single number gap. And then we start back up at 1/2, and 1/2 goes all the way to infinity right here. Okay, infinity is always round, and then I make the 1/2 square bracket because it is a square bracket here. Okay, so the infinity and negative infinity are always round. The other numbers are going to have their brackets will be based on the brackets that are here. Okay, and so that's exactly what I did right here in this answer. Don't circle that yet, though. We still have to consider the, like we said in the front side of the worksheet that we're currently working on here. After you consider the numbers that make the inside of the square root greater than or equal to 0, you then have to take that set of numbers and remove from it which x values make the denominator equal to 0. What x values, again, make the denominator equal to 0 up here? Okay, what makes the denominator equal to 0 up here when you actually figured out what this, in other words, when they say the denominator equal to 0, they're talking about the original composite function f circle g. You can see there's one denominator here, it's x. And so they're asking, what makes that denominator x equal to 0? Okay, so since the denominator, let's write this down, since the denominator is x, okay? And obviously, the denominator would only equal 0, only equal 0 when when you plug in x equal to 0. You plug in x equal to 0 into x is going to be equal to 0. That's the only thing that would make it equal to 0. Okay, then that's going to be the thing that would make the denominator equal to 0. It's just the number 0. Okay. But 0 is, see, normally you would remove that from the answer that you just got from the radicand part. Normally you would remove it, but because there's a round bracket right there, that means the 0 already is not in the domain already that we came up from this, from the radical part of the problem here, the radical part of the domain. Okay, so again, like it says on the front side of the worksheet, you're supposed to remove the 0 from the answer you got from the radical part, but it's already removed because the 0 has a round bracket next to it. Remember, a square bracket next to 1/2 means that 1/2 is in the answer. It is a part of the domain when the square bracket's next to it. But if a round bracket's next to a number, that number's not in the domain, just the numbers next to it. Okay, numbers next to 0 are in the domain, okay, that are to the left of 0, as we can see up here, you know, like negative 0.1, negative 0.2, those kinds of numbers, but 0 itself is not. So you don't need to do anything here. Okay, if 0 was in the domain, we'd have to adjust the answer to make sure it's not. But, and we'll see an example like that in the next example, don't worry here, when we do G circle F. But because, since 0 is already not in the domain, then this right here is the domain. Whoop. Need a square bracket right there. This right here is the domain. The domain of F circle G. Okay? Now the domain for G circle F is going to be a bit easier than this. Okay? All right, it's not so tedious. All right, let's take a look at what that's going to be. So let me write that down over here. Okay? Right underneath where I was going to skip problem number 6 there. G circle F. As promised, we got to figure that out first. What is G circle F first, and then we'll figure out the domain. G circle F means that we got to plug in the second function, the square root, into the x from the first function. This time G is the first function. So this is what it's going to look like. Since F is the second function, we are going to plug in the square root into G. And so it's going to look like this. Like that right there. Okay, so now to find the domain, you guys, we need to do what? All right, and again, just to go back here, this was F circle G right here. Okay, just to circle my answers. I already circled the domain answer. This is the answer for the G circle F, but we still got to find the domain of it. Okay, so the domain, how do we figure that out? Again, we start out with the radicand, the thing inside the square root. We ensure that it's greater than or equal to 0. Much simpler inequality this time. When you have a linear inequality, okay, what you got to do, and this is linear because it's not, it doesn't have a fraction in it like this, okay, and it doesn't have an x squared in it like there's also quadratic inequalities out there, but this is just x with no fraction in it. When that's the case, when you have those types of inequalities, you just get the x by itself, just like a linear equation, and then you put it on a number line. So we'll review this. This is just a problem, an example of a linear inequality here. You get the x by itself, okay, and so I'll review this stuff with you here. But what you got to do, just like with a linear equation, you got to move the 4 and the 0 onto the same side. And then you would normally divide out to get the x by itself, but because it's already x, instead of being 2x or 5x or something like that, then you're already done here. You just got to do the number line thing, just like we did in the F circle G part. Okay, but this number line's a lot simpler when you're doing a linear inequality instead of the ones with fractions in it. You put the -4 on the number line anywhere you want. Okay, and then here's how the linear inequalities work. All you got to do, okay, again, these are the ones that don't have the fractions, don't have the x squareds in them. Okay, just those ones I'm talking about here. Okay, if it says that the variable is greater than, it doesn't matter what side it's on, okay? If it had said this right here, it would mean the same thing, okay? I know this reads as -4 is less than or equal to x, but we need to focus on the variable. If the variable is greater than or equal to -4, which this says here, okay, because the x is on the right-hand side, so here the x is greater than or equal to -4. Here the x also is greater than or equal to -4. I just want to remind you that no matter what side the x is on, you got to look at it, you got to read it so that you read the x first. So you know what is going on with the x. X is greater than or equal to -4. X is greater than or equal to -4. No matter which way you write it, it's the same thing. And when the variable is greater than, okay, a number, you always go to the right. This is just with the linear inequalities, like I said. Okay, if the x had been less than or equal to, then the shading would have gone to the left of the number. Okay, so we're done with the shading now once you do that, when you're doing a linear inequality. So what you do is since this is has the equal to thing again, you do a square bracket on that, just like we learned in the last part. But there's no denominators to worry about right here in this particular thing, this inequality. I'm not talking about the whole problem. I'm just talking about in the linear inequality here. Okay, eventually we're going to deal with that denominator, but just looking at the radical part, not the denominator part, but just the inside of the radical. Yeah, normally we would, in fact, we would always make this, unless you got that denominator issue that we're not going to worry about here yet until we get to the denominator part. But just the radical part, it's always going to be based on the fact that this has the equal to. If it's the equal to, you use the square bracket. If it didn't have the equal to, you would use the round bracket. So this is the number line for the radical part. We're just trying to figure out what numbers come from the radical that are going to be in the domain, and then we'll do that denominator thing at the end like we did in the F circle G example. So what is the interval notation here? The interval notation here would be -4 to infinity, because that's where the shading starts and where it ends. We put a square bracket here and a round bracket here. Square bracket because that's square, round because infinity is always round. Okay, however, the difference between this problem and the last one is that now we have figured out what? We figured out what numbers are okay for the domain as far as the radical is concerned. So now we have to remove, as the front side of the worksheet says, we have to remove the number that makes the denominator equal to 0. And this time that number is in this domain. Okay? The number that makes the denominator equal 0. What number makes this denominator equal to 0 up here? Okay? Well, x plus 4, square root of x plus 4. Okay, let's write it down here. The denominator is the square root of x plus 4. Okay? So what we do is we set that equal to 0, and then we figure out what is the solution to that equation. Okay? What is the solution to that equation? So, a little review here of equations that have radicals in them. This is an equation because of the equal sign, and then it's got a radical in it. When you have an equation with an equal sign in it, if you've got a radical on one side and then not a radical on the other, we square both sides to make the radical disappear. Okay, so we're going to do that same thing here.
That was just an example I was showing you from a radical equation. So I square both sides. It makes the radical disappear. And then this looks very similar to what we did up here up above. It's just that it's an equal sign this time, but the way you solve it is the same because it's linear. It doesn't have the x squared in it or a fraction or anything. We move the 4 over to the other side, so the answer there's -4. Now, what is the significance of that? That's the thing that we need to remove, okay? We have to remove that, okay? So we need to remove -4. We remove x equal to -4 from what? From this, okay? From this thing. Now notice here that the -4 has a square bracket next to it. So -4 is in this answer here, unlike in that last part where I already said that, oh, the 0 is already not in the answer, so you don't need to remove it. Here the -4 is in the answer because it's a square bracket. If something has a square bracket next to it and you want to remove it, guess what you got to do? You just got to change it from a square bracket to a round bracket, because remember, like I said, when you have a round bracket with a number next to it, that number is not in the answer. So here it was in the answer, talking about -4, and now it isn't. And that's the only thing I wanted to remove, you guys. And so don't change anything else. The infinity's still there and all of that. So thus, let's finish this up here. Thus, so we got this we removed it to get this. So thus, -4 with the round bracket now up to infinity is the domain of G circle F. Okay? And so there you go right there. And so that is how you figure out the domain. Remember, do the radical part first. Do that greater than or equal to thing. Okay, figure out what you got just from the radical part. Don't worry about the denominator yet. That's why I had a square bracket here. Okay, eventually it turned round because we knew that the -4 was not going to be in the answer and everything. But just in the radical part, do that first. And then remove, if necessary, whatever makes the denominator equal to 0. Whatever x number makes the denominator equal to 0. Okay, and so I figured that out by setting the denominator equal to 0. That's how you do it. Okay, you solve that equation after you set the denominator equal to 0. Then you remove that number, and then once you've removed what makes the denominator equal to 0, then you're set. Okay, so that concludes section 2.8.